Welcome back for another MikroTik video tutorial. We have our 9 MikroTik routers powered up, but this time, instead of viewing them all, we could use filter in our Winbox version 4. Then identity, of course you have some selections here. So identity contains, so anything with an identity that containing 65100. So click apply. So it will only show our 3 routers, R1, R2 and R3. So let's connect to our R1. So type in the password, click connect, and we are at our R1 router. As a quick recap, so we have our IP addresses from Ether 2, Ether 3 and the loopback. As such, we have our router ID dynamically set. We don't have any manual, but it's dynamically set to take the router ID or IP address of our loopback interface. Our main objective for this video is to have network reachability to the other routers in our group. So for example, in the 65100 group, we have R1, R2 and R3. So for example, we are 10.112.1. Can we able to ping 10.112.2, which is our R2? Yes, we are able to. Can we ping 10.113.3, which our R3 router? Yes, we are able to ping our R3 router. But the question right now is, do we have full network reachability? So for instance, we have R1 in our left, R2 in our right. We were able to ping 12.2 just now from our R1. But the question is, could we ping the other interface IP on our R2, which is the 10.150.2, or even its loopback interface 172.30.100.2. Let's try the other IP, ping 10.150.2, so no route to host. And we can also try the loopback address of R2. So ping 172.30.100.2. We are .1. We are trying to reach .2 and same, no route to host. So how about from R1 to R3? So 10.113.3 was successful, but how about 10.100.200.3? Okay, so we open ping tool in our R1, click start, and you still have the same no route to host status. That should be presumably the same case if we try to reach the R3 loopback address. So 172.30.100.3, click start, and still the same, no route to host. Now that we found out that it doesn't mean that we have already the correct IP address set on the physical interface as well as the loopback on all the 3 routers, and it automatically able to communicate. So the answer is no. We are only able to communicate or to reach our directly connected router. So we need IP routes or the correct routes to the destination that we intend to. So for example, we are only to reach our own subnet, but we will not be able to reach the other loopback address because we don't have a route. As such, the error just now when we do a tools ping was no route to host. We could address our requirement for network reachability by going to IP routes and creating a new route. But for the purposes of this video, we will not go to this route solution, but instead we will use a dynamic routing protocol. For example, open shortest path first, or OSPF. So we will learn what is OSPF, how to configure OSPF instance, configure OSPF area, configure interface templates, set up OSPF priority, and state some passive interfaces. And finally, we'll do some OSPF route redistribution. OSPF, or Open Shortest Path First, is a dynamic link state interior gateway protocol. Let's create an OSPF instance. So go to instances, click new. So enable check. You need to have the name, so version, either version 2 or version 3 for IPv6, the VRF, the router ID, which we only have one, and the other settings, which could be discussed in future videos. But for now, I will leave the defaults, but I will just uncheck first the enabled and just check it later. So click OK, and we have the OSPF instance, but still in a disabled flag or state. Next, from instances, we go to areas, so click new. So enable check, so the name of the area ID, so we will use first the backbone area and leave the other setting as default. So we will check it enabled, click OK. So it mentioned here OSPF instance not active. Yes, we are aware because we have unchecked the enabled. So after areas, we go to interface templates, and let's create our OSPF interface template. So OSPF interface template enabled, so interfaces, area, so networks, and we will set some priority later, and passive interface. So area is there already, our OSPF area 1. So we could add in networks, but let us try first interfaces. So need to add the loopback, then going to our Ether 2, and also going to our Ether 3, which is to the R3 router. So area is OSPF area. We'll just leave it as default for now, as this is a basic configuration, and the OSPF timers are on its default. So click OK. So we need to set the priority, but just now I didn't set because I still need to tell you what is that for. So in OSPF, there is such thing as designated router, and it is elected based on the highest priority. So for R1, we will set it as the higher priority between R2 and R3. Let's go back to this configurations, area not active. So let's set the priority as 250. Click OK. Next will be our passive interface. So if passive is set, it will not send or receive OSPF traffic on any matching interface on that interface template that we set as a passive interface. So let's do that. Interface templates, click new, and the interfaces that we want to set passive is Ether 1, plus sign going to Ether 4, and plus sign going to Ether 5, because we don't expect any OSPF routers in this interface. So we could set priority here, so 250, and the passive is set. Okay, so these are the interfaces that we want to set passive. Click apply. Let's configure the other router, R2, so routing OSPF. Then we go to the instances, so new, we'll accept the default. We'll uncheck or check the enabled. Later on, we'll check the enabled on the other side. We don't have any changes here, so click OK. Next, we go to area, so click new, we will accept, we'll click enabled, we'll stay put with the backbone area ID, so click OK. Next will be our interface template, so click new. So we have routers on our loopback, and we will also select Ether 1, and area is OSPF area 1. That's okay. Then the priority will be a lower one, which is 200. Okay, so click OK. Then let's create our passive interface. So our passive, we don't have any OSPF routers on Ether 2, on Ether 4, and on Ether 5. So we'll check passive, we'll put in our priority, click OK. So back in our R1 MikroTik router. So as you notice, I purposely didn't configure any networks, but only configured the interfaces, and it's showing OSPF air not active because our instance is not yet active. So now let's try to enable the OSPF instance and see if there is any neighbor that will be formed despite that we didn't configure the network. So let us try if only interfaces will suffice. Let's go to instances. Let's come back here and enable. Okay, so click OK, and you can also click enable here. You don't need to double click. So we go to neighbors and see if there is any neighbors that are formed. Okay, so there's neighbors that are formed despite we didn't configure the networks on the interface template configuration. So it is also the same on the router 2, which is only interface templates, and it was already enabled, awaiting for our R1 to be enabled, and we have now the neighborships formed. If we go to LSA, link state advertisements, so we have this router. So the originator is the loopback IP of router 2, as well as there is also a network LSA. So the originator is the 172.30.100.2, which is R2. So let's check on our IP routes if there is any addition, and yes. So among the connected routes, we now have DAO, or small letter O stands for OSPF, or it means OSPF. And yes, we are able to get the 172.30.100.2 route from our OSPF. So let's do a tools ping for verification. So tools ping, and we type in, or we maximize first, we type in 172.30.100.2 and click start. And yes, there is a reply. There's no route to host status anymore, and we are able to reach the loopback of our R2. We are at our R3, and this time let's do command line instead of GUI. So R3, so /routing space OSPF, and we can press F1. So we will begin with the instance. So instance, then you can also have F1. So add, so F1. Then we could select first the disabled. Okay, so or choose or type disabled no. Then the name of the instance, so OSPF instance 1, that's our name. So we'll just stay put with the other settings, VRF and so on and so forth. So let's try to enter. Okay, so let's do a print in our instance. Okay, so we have, or also we could verify in our GUI, so routing OSPF and instance, and yes, we have an OSPF instance. Next will be OSPF area, so routing OSPF area, then F1, so add F1, and we could type in the disabled first. So disabled equals to no. Then after that is the name. So it will be OSPF area 1. Then finally the instance, which is our OSPF instance 1. Enter. So we could do a print similarly. So routing OSPF area print, or we could go to routing OSPF, then area, then we could have our area. Next will be routing OSPF interface template. So interface hyphen template. So F1. So you'll have the add F1, and you'll have this configuration that are needed. So we type in disabled equals no. So next will be the instance ID. So if we go to our routing OSPF, obviously I could do a command line as well, but for simplicity, so routing OSPF, if you go to instances, okay, so it is starting with 0. So let's type in instance ID equals to 0. Next will be interfaces equals. So you'll add in the loopback as well as the ether 1. Then the priority will be 200. Okay, so routing OSPF interface template, add disabled no, instance ID will be 0, the very first instance, interfaces will be the loopback and ether 1, and priority is 200. Still need the area, so area will be OSPF area 1. This is the area identifier that we have typed in or configured. Okay, so it is accepted, so I could just go to routing OSPF and we have the interface templates, so it's added already here. Or of course we could just do a print and it also appears here. Now that R3 has configured its OSPF via command line or via CLI, so if we go back to R1 and go to neighbors, there is now this OSPF of the 10.113.3 or from the router ID of router 3. So if we go to IP routes, and we should see another additional DAO or OSPF route on the loopback IP of our R3. So let's do a tools ping. So tools ping to 172.31.100.3. Click start, and yes, there is a reply to our R3 loopback interface. So we have tested that from R1 it was able to reach the directly connected 12.2, and we are also tested just now with the OSPF configuration, we are able to reach the loopback IP. But how about the remaining interface IP of R2, which is 10.100.150? So if we take a look at the IP route of our R1, we don't have a route towards that destination. So we have from 10.100 and we have 172.31, but we don't have 10.100.150. So it's 12 and 13. So we don't have the third octet to 150. So if we try to ping now, we will still fail to reach this IP address. What we need to do is OSPF route redistribution, which is the process of importing routes learned from other sources such as static routes, connected networks, or different routing protocols into the OSPF routing domain. So in our case, it's a connected network. Let's see if we can configure that. So it will be under instances. So double click, no need to create new. So on the same instance, so we just need to edit. So we scroll and find the word redistribute or setting, redistribute. So click plus. So we'll just select or check the connected. Click OK. So now after the route redistribution of connected networks, so the 10.100.150.2 on our R2 appears now on the R1 IP route list, which is an OSPF route. So we have 10.100.150 network. So let's do a quick ping, 10.100.150.2, click start, and yes, we are able to reach the Ether3 interface of our R2 from our R1. Then finally, how about our R3? So we are able to reach the loopback, we are able to reach the directly connected interface 13.3. But are we able to reach 10.100.200? So the answer is no, because we don't have any route. We don't have default route as well. So these are the routes that are only in place in our R1. So similarly, at our R3, we need to set the route redistribution. So routing OSPF instance print. So this is the instance that we need to configure or set a value for the route redistribution. So we have routing OSPF instance, then F1. So we will not add, but we will set. So because we need to change the property, so set F1. So we need to have the redistribute, and the numbers will be the 0. Okay, so set 0. Then we'll have the redistribute, and if we equals, so we have the choices. So connected will be our setting, so enter. So that is the CLI command for setting the redistribute connected. with our redistribute CLI command correct. So the 10, 100, 200 net network now appears in our route list in our R1. So we have a new DAO OSPF route to 10, 100, 200 net network. Finally, we can do a ping test. So 10, 100, 203, click start. And yes, there is reachability now from our R1 to the Ether3 interface of our R3 router.